Hey there, chemistry students. This is Miss Ruark. This is a practice problem vodcast for you so that I can go through the remainder of the practice problems from the worksheet that we were working on in class, so you'll be able to watch them and understand how to do them. All right, so question number 3 says, what is the molarity of a nitric acid solution if 43.33 milliliters of a 0.1 molar KOH solution is needed to neutralize it? All right, so we know that we're going to use nitric acid, HNO3, and we're going to neutralize KOH with that. So we're going to form on the other side H2O and KNO3. And then we double check to see if it's balanced, which it is. And we know that we're going to be using 43.33 milliliters of this KOH solution. And this KOH solution has a 0.1000 molar concentration. We know we're going to use 20 milliliters of the acid solution, but we don't know the concentration of that. That's what we're looking for. Okay, so whenever in doubt, we go to moles. What do we use to go to moles? The thing that we know, not what we're looking for. So we're going to use this to go to moles. All right, so how can we go to moles from there? Well, let's set it up into our molarity equation. Okay, we know 0.1000 molarity is equal to moles. That's what we're looking for, over 0.04333 liters. Why is it changed? Because we went to liters from there. Okay, so basic algebra, we're going to rearrange our equation and solve for moles. Now you guys know how to do this, so I'm not going to repeat it. Get rid of the fraction, multiply by the denominator, right? Okay, so moles here of KOH, that will give us 0.1 times 0.04333, which gives us 0.004333 moles of KOH. We don't want moles of KOH, we want to find this right here. So we've got to go to moles of HNO3. So we use our mole ratio. It is a 1-to-1 ratio, so 1 mole of KOH and 1 mole of HNO3. Okay. Moles cancel. And, well, let's go ahead and solve for that. So that will give us, since it's a 1-to-1 ratio, it should be the same number. This is now moles of HNO3. Okay. So the first thing we did was we found moles of the substance we knew. Then we used that to change to moles of the substance we're looking for. Now that we have moles of the substance we're looking for, we need to find the molarity. And remember here, molarity is moles over liters. Well, we have moles, we have milliliters, and we can change that into liters, 0.02000 liters. Okay, so now all we have to do is take that and divide by 0.02. And when we divide by that, it gives us 0.21665 liters of HNO3. Not liters, sorry, moles over liters, which is molarity. All right, how many significant figures? We have 4 here, we have 4 here, we have 4 here, so we need 4 significant figures in our answer. So this becomes, I'm going to write it up here, 0.2167 molarity HNO3. Right? You see it's the same thing over and over again. All right, let's go to question number 4. What is the concentration of household ammonia cleaning solution if 49.90 milliliters of a 0.59 molar HCl is required to neutralize this solution? So ammonia, NH3 plus HCl. You okay? All right, and so now we've got to figure out what our products will be. Now, the nice thing about an acid-base solution or an acid-base titration is you don't really have to form your actual products over here. So we can take these and change them into our conjugate acids and conjugate bases. How sweet would that be, right? So this NH3 is going to become NH4 positive, and this HCl is going to become Cl negative. That is so cool, isn't it? Yes, because then we don't have to worry about taking these two and forming them together. We know when we put them together, we're going to end up with water somewhere, and the water doesn't come from here. It comes from the water that's in the solution with it. Why? Because this is a weak base and this is a strong acid, so it doesn't always break down to form water and a salt. That's okay if you didn't get it. Just know that you can, instead of working through the full equation, you can take it and work to the conjugates and just go from there. it still does the same thing. All right, so double check if it's balanced or not. It is. All right, and now we know that we have 49.90 milliliters of this solution, and the concentration is 0.5900 molarity. We know that we have 25.00 milliliters of the HCl solution, and we want to know what is the concentration. Okay, same steps as before. Let's use this here to figure out our moles. So if molarity is equal to moles per liter, molarity is 0.5900. Moles is what we're looking for. And we have that many milliliters, which is 0.04990 liters. Okay, solving for moles, simple algebra. We're going to multiply by our denominator to get rid of the fraction, right? Get rid of the fraction first. Okay, so this will give us moles of, well, let's see, I'll write it up here. That gives us here. All right, it gives us 0.5900 times 0.04990. It gives us 0.029441 moles of NH3. Right. Now we need to go from moles of NH3 to moles of HCl. 1 mole of HCl, which gives us 0.029441 moles of HCl. Okay, we're good so far, right? Well, now we need to find the concentration. So to get the concentration, we need moles over liters. So we put moles over 0.02500 liters. Okay, and then we divide 0.02500 liters. And the calculator gives me 1.17764 molarity. 4 significant figures, 4 and 4 significant figures. So we're going to keep that right there, and it becomes 1.178 molarity HCl. And there's your answer. This is easy stuff, right? Okay, it should be easy. I hope it's easy. Okay, question number 5 says, how many milliliters of a 0.5 molar NaOH would you neutralize? Blah, 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 blah. Okay, so we know that we're using NaOH, and we're going to use H3PO4. All right, so on the other side, what's going to happen? We're going to end up with Na3PO4 and H2O. Okay, and then we look, is it balanced? No, it's not balanced. We have 3 hydrogens here, 1 phosphate. We have 2 hydrogens here, 1 phosphate, 3 sodiums. So let's put a 3 here, and then we put a 3 here. All right, so we've got a 0.500 molar solution of this. We're going to use that. It says how many milliliters do we use? And we're going to use that to neutralize a 0.100 molar solution, which we're going to use 25 milliliters of it. Okay, same steps as before. Moles is equal, or molarity is equal to moles over liters. Okay, so what do? We plug in 0.100 molarity is equal to moles of H3PO4 over 0.02500 liters. Okay, so 0.1 times 0.02500, and we're left with 0.0025 moles of H3PO4. Okay, now we need to do our mole ratio. So we know that we have 3, ooh, look, it's different, 3 moles of NaOH for every 1 mole of H3PO4. So that times 3 gives us 0.0075 moles of NaOH. And they want to know how many milliliters NaOH are we using. So we have to use this, and we're going to plug it into M is equal to moles over liters. Our molarity is 0.500 M. Moles is 0.0075 moles over liters, because that's what we're looking for. Okay, so do your basic algebra, rearrange your equation, and you should end up with 0.015 liters, which would be 15 milliliters. But we want three significant figures, so we would have to end up putting, I'm going down here, sorry, 15.0 milliliters of NaOH. Uh-oh. Uh-oh. Whoa. Okay, sorry guys. There we go. Okay, and that's how you do it. I know I went through it quick, but you've got lots of practice problems here for you. You've got more practice problems on your paper. Please let me know if you have any questions, and I will see you later.